Okay, illustrative math, unit 2, lesson 12 is called polynomial division, part 1. So our goal is I can divide polynomials by using the box method. Okay, so basically we're going to use a box to do division of polynomials. All right, what do you notice? What do you wonder? Take a minute, pause the screen, see if you can find a couple notices and a couple wonders. Okay. So we'll write up here, notice. All right, so the box on the right is a way to multiply the polynomials. All right, so we're taking x minus 3 and x minus 5, or x plus 5 right there. We're multiplying them. So we multiply each term, okay? Another thing, the number of squares inside the box is equal to the number of terms in each polynomial multiplied together. Okay? So for example here, if I go over here, I have two terms in this box, or this polynomial, two terms in there, 2 times 2 is 4. If you look right here, I got 1, 2, 3, 4 squares. Here I got 2, and here I got 3. I have 1, 2, 3, 4, 5, 6 squares. 2 times 3 is 6. All right. This one is a little trickier, so that's a wonder. I wonder what the second polynomial is. Okay. So let me go back over here. Let me add that in as a wonder. I wonder what is the second polynomial in example C. I wonder, is there enough information in example C to finish the box? What else? Why are we using a box to do multiplication? How about why do you always get the number of terms equal to 2 factors equal? How do you get the, how about this, the total number of terms in the box equal to the product of the number of terms of the factors? Okay, that's kind of really a notice reworded as a question. It's just asking why that is. So yeah, so this is some good stuff here, but I want you to definitely, after we start looking at that, take a look and see here the x minus 3 goes right there. The x plus 5 goes there. So your factors go on the top, and then you multiply. So x times x is x squared. X times 5 is 5x. Negative 3 times x is negative 3x. And negative 3 times 5 is negative 15. Now, you might say, how do we get from here? How do we get from here over to there? Well, when you combine the like terms, the negative 3x plus 5x, I get 2x. You add the coefficients. Negative 3 plus 5 is 2. All right, kind of the same thing over here. Your factors go here on the outside of the box. And then just multiply everything through. So that will give us these values on the inside. And then if you look here, negative x squared plus 3x squared, that'll give me the 2x squared. And then negative 3x minus 4x, add those, we get negative 7. And then there's no like terms with the x cubed, and the force of those just kind of stay the same. All right. Now, when we go to this one, this one's a little trickier, but you can kind of start filling it in. And this will be what we're going to learn a little bit of today. We know the x cubed is here, so x times what would give me x cubed? Well, we know that this would have to be an x squared. And then we could say, oh, okay, well, I could fill this in. X squared times negative 2 is negative 2x squared. And then we could kind of say here, oh, well, we need the negative x squared term right here. So this one here plus this one would have to give me adding up to negative x squared. So that would have to be a 1x squared, because when I add these two up, negative 2 plus 1 gives me negative 1. And then you can kind of work backwards here. So x times what right here would give me x squared. That'd be x. Now we can multiply here. Negative 2 times x is negative 2x. Then you see here, this has to be a negative 4x. So this would have to add up. Negative 2x minus 2x would give me the negative 4. X times negative 2 right there would give me negative 2x. And then the last one would give me 4. And now I filled in the box, and it all equals that. So I guess we could answer that question. Is there enough information to finish the box? The answer is yes. Okay. What is the second polynomial for C? Actually, we answered that. So it would be really x minus 2 times x squared plus x minus 2. All right. And there's actually a way to factor that even further to make it linear, which we'll get into later. All right. Priya wants to sketch a graph of the polynomial f defined by f of x equals x cubed plus 5x squared plus 2x minus 8. She notices that the coefficients of the terms of f of x sum up to 0, which means that 1 is a 0 of f of x. Is she right? Well, if I plugged in 1 here for x, it should equal 0. 1 cubed plus 5 times 1 squared plus 2 times 1 minus 8. That gives me 8 minus 8. That would be yes. Okay. So if x equals 1 is a 0, then my factor is x minus 1. So that's where we put the x minus 1 there. So Priya wants to sketch a graph of this polynomial. She knows that f equals 1 is 0. So she suspects x minus 1 could be a factor. So then she writes the polynomial equals x minus 1 times something. Okay, so write f of x as a product of x minus 1 and a factor. So we're going to make this box here. We're going to go backwards here. So we know that this is going to have to be x squared. We put the lead term right here. So that was x cubed. And then I know that x times x squared is going to give me x cubed, and negative 1 times x squared is negative x squared. Then I go to the x squared term and I realize, oh, okay, this has to be negative 5x squared. So this would have to be a 6x squared. Add those up. Negative x squared plus 6x squared gives me the 5x squared. So x times 6x would give me that. So then I can multiply these. Negative 1 times 6x is negative 6x. You know your constant is negative 8 here, so I could just fill the constant in here. You're always going to put the lead term and then the constant term in the top left for the lead term, bottom right for the constant. Negative 1 times 8. And then this one would be 8 times x. Okay, you're just kind of working backwards there. So this would mean x minus 1 times this would give me that, which when I simplify that all, it equals the x cubed plus 5x squared plus 2x minus 8. So I'm going to write it as x minus 1 times x squared plus 6x plus 8. So now I got to get it as 3 linear factors. So this one's linear here, the x minus 1. So I'm going to keep that. This is quadratic. So what I need to do is I need to see if I can if I can do another box here and maybe get that. So here's my box. Okay, so I know my highest power is x, or my lead term is x squared, and then I put my constant right here. So I got to think here. This is a little bit of a guess and check. So x squared is easy. It's got to be x times x. Now 8. What numbers could I multiply to get 8? Well, I got 8 times 1. I got 2 times 4. And I also have negative 8 times negative 1 and negative 2 times negative 4. Those would both give me 8. So remember, these two here have to add up to give me 6. So I think the two that are going to work is 2 and 4. So I get a 2x and a 4x. And if I add those up, I get 6x, which is what my polynomial had. This has to match up what those add up to. So now this is called factoring it. So it's factors. Factors are things that you multiply. So we have 1, 2, 3 factors. So if I multiplied all that out, that would give me x squared plus 6x plus 8. All right, let's make a sketch. Okay, so I'm going to do this. I'm going to put my x-intercepts on the graph. -1. No, it's +1. Sorry. If my factor is x minus 1, that means +1 is an x-intercept. I have +2, and then I have -4. Now here's the thing. My end behavior, or my y-intercept's -8, so I could put that on there too. I'm down here somewhere at -8 for my y-intercept. And then my end behavior, it's an odd positive. So my end behavior, right side goes up, left side goes down. So what I'm going to do here is I'm going to go to my far left 0 and I'll make sure that goes down. Go to my far right 0, make sure that goes up. They all have a multiplicity of 1, so they cross through. Wait, that doesn't look right. I just don't have enough space on this. Let me redraw that here. So I put my x-intercept of -4, 2, and 1. So this side goes up. I'm going to dip down, come up, and come through -8. No, something's wrong here. Why am I wrong? Hold on. -4, 1. Oh, here's my problem. This is a +2. That's my problem. Should have been a +2. It's x and 2. So that would make my intercept here. There we go. That makes a little more sense. So the right side up, left side down. I know my y-intercept's down here at -8. So I'm going to cross through here and come up and back down. A little sloppy. If I were to, let me redraw that. So I'm at +1, -2, -4. So this side goes up, and then it comes. There you go. That's a little bit better. And this is at -8 right there. All right. So here's some polynomial functions and known factors. Rewrite as a product of linear factors. Note, you may not need to use all the columns in each diagram. For some problems, you may need to make another diagram. So we know that this is x minus 7. So we put one of the factors on the side. And then here's the thing, x cubed. Okay, we're going to start here with x cubed. So we'd fill this in. this actually wouldn't be here, okay? But you know, x times x squared will give me x cubed. So I'm going to just fill that in. I take x squared times -7, and I get that. So now I got to go over here, and I got to start looking. Okay, what would I have to add to -7x squared to get -7x squared? That's 0. So that's easy. So x times 0 would mean this would have to be 0 here, because 0 times x to get 0 would have to be 0. So then 0 times -7, you can fill that in as 0. And then we go here. So this would be the x normally. So we need my x's to add up to -16. So this would have to be a -16x, because you're thinking of these like a 0x. Okay. Or, yeah, because this is x cubed, so you want these to be x squareds. So you think of it like 0x squared, which we can just say 0. I'm sorry, that would be 0x, sorry, because we want this to be 0x squared. So I'd have to multiply that by -16, and then I can multiply that here, and I should get 112, which I do. Okay, so we now got it down to x minus 7 times x squared minus 16. Now this is not linear though, okay? We need to make sure that it's a linear factor. So I'm going to have to do another box here. So I'm going to maybe put my box right here. And let's see if I can figure this out. So I know the x squared goes here, -16 there. That's got to be x and x. So it's really x squared plus 0x minus 16. So if I did a 4 and -4, that would give me the -16. And then 4 times x and x times -4. These will cancel out, give us 0, which would give me x squared minus 16. So final answer here, let's see, I'll put it right here, x minus 7, x plus 4, x minus 4. So we went from polynomial form down to factored form. So we could say our x-intercepts are 7, -4, and 4. All right, next one. So we know that this is a factor, so we put that there. And we know 2x cubed. So what I might start doing is I might start putting the constant down here, because we know that that's got to be a 36. So that'll help us. So again, this wouldn't be here. So you're kind of just saying x times what would give me 2x cubed. So we need a 2 and then an x squared. So there it is. So then this times that would be -3. All right. And if you're having trouble with the math here, those cancel. So it's -3. A lot of times fractions throw people off. Let's see here. So how did they know? Then they kind of filled this in here. How did they know this was a 2x squared? Well, they said your x squared had to be -1. So this is -3. You're going to combine these two terms. So this would have to be a 2, because 2 minus 3 is -1. And then we could fill this in. X times what would give me 2x squared? Well, we need a 2x. And then I can multiply these. So -3/2 times 2 would be, or times 2x. The 2's cancel, so it's -3x. Here we go. We could fill this in here. You could do this one a couple ways. You could say -3x plus what gives me -27, and that's -24x. X times -24 would give me -24x, and then double check -3/2 times -24. Just write it out here. That gives me positive 36, so we're good. All right, so let's see here. What I did was I got it down to x minus 3/2 times 2x squared plus 2x minus 24. So I got to get this into a linear factor. This is linear because it's x to the first. This is quadratic because it's x squared. So I make another box. And we put the 2x squared here and the negative 24 here. So these are a little harder. You got to do a little guess and check here. So I know one of these has to be a 2x and an x to get that. And then I got to think, I need numbers that I can multiply to get negative 24. But they also have to add up to 2. So I think if I did like a 6 and a negative 4, let's see what happens here. This would be negative 8x, and this would be 6x. These add up to negative 2. We need to be positive 2, so let's do this. Let's change the signs. That would make this positive 8x and this negative 6. So 8 minus 6 gives me the 2. So now I got it. I got x minus 3 halves times 2x minus 6 times x plus 4. There it is. And that's equal to b of x. And this one was equal to a of x, I guess. So remember, this is your answer. So what are my x-intercepts? You'd have to set each one of these equal to 0. So I think we get negative 4 here. This would be positive 3, and this would be positive 3 halves. All right, last one. All right, so x and x plus 3. So this time they left everything blank here. So I'm going to put x cubed right here, and then I'm going to put my constant down here. Okay, that'll make things a little bit easier. So x times x squared, and then we can multiply this. This would be 3x squared. So this one's, what am I adding to 3x squared to get negative 3x squared? So that would have to be negative 6x squared. Add those up, that'll give me that middle term there. X times negative 6x, that would give me this term. So then I can multiply these. This gives me negative 18x. And then I have to add, what do I add here to negative 18 to get negative 13? So that would be a positive 5. And then x times 5 would give me that. So cool, I got it down to x plus 3 times x squared minus 6x plus 5. So this is not linear, so I need to make another box. All right, this is a 2 by 2 box because it's quadratic. So I put my x squared here, and I put my 5 here. So this is going to be x times x. To get 5, the only way I could do it is 5 and 1. But here's the problem. Check this out. This gives me 5x. This gives me 1x. When I add these up, I get 6. I need it to be negative 6. So these have to be negative. And it still works because negative 1 times negative 5 still gives me positive 5. And then when you add these up, negative 1 minus 5, that's how I get the negative 6. So I end up with x plus 3 times x minus 1 times x minus 5 equals c of x. All right, and again, your x-intercepts here are going to be negative 3, 1, and 5. All right. All right, a couple more here. This is getting a little more intense. I'm going to maybe make my box over here. So here's the thing. They gave us a hint here. When I skip a power, you should probably fill in a 0. So I skipped the x cubed and I skipped the x, so I filled in zeros. That will help me. All right. Now, you might be asking yourself, well, what do you start with? You use the x minus 2 or the x plus 2. It really doesn't matter. I'm going to use the plus 2. But you can use them either way. You'll get the same answer. Now, when I have squared, I have 2 columns. When I had cubed, I have 3 columns. And now when I have to the 4th, I'm going to have 4 columns. So I'm going to cut that down. All right, so put my x to the 4th here, and I'll put my 36 down here. So it's x to the 4th So 4 columns. So let's think here, x times x cubed. That would give me 2x cubed. These two have to add up to 0. So this is going to be a negative 2x cubed. So x times negative 2x squared would give me that. So then I can multiply here, I get negative 4x squared. So I need these two to add up to give me negative 13. So that would be negative 9x squared. Now I say x times what would give me negative 9x squared? That'd be negative 9x. And then these ones, these are easy. If you have the outside, you just multiply them. Okay, now these are easy too. You just add them up. These need to equal 0, so that's going to be positive 18. And then x times 18, and then double check your constant. It works, okay? So we got it partially factored. We have x plus 2 times x cubed minus 2x squared minus 9x plus 18. So I still didn't, I used the x plus 2. I didn't use this yet. So when I make my second box, this one's going to need 3 boxes. So it's going to get a little crazy. All right, let's do this x minus 2 into that polynomial right there. So I'm going to put my x and my negative 2. And since this is basically, I'm dividing into a cubed, I really am only going to need three columns here. So all right, so this is going to be x cubed, and this is going to be 18. So ready? X times x squared, and then I can multiply this. It's negative 2x squared. And then these have to add up to negative 2x squared, so this is going to be a 0x squared. So that would be x times 0x. And then when I multiply here, I get 0x here. And this has to add up to negative 9x, so that would have to be a negative 9x. So this would have to be a negative 9. And I double check because it should all equal out to that constant. Negative 2 times negative 9 is 18. So now I have x plus 2 times x minus 2 times x squared minus 9. So I got to get that into a linear. So I make one more box here. And I put my x squared here, negative 9. X squared is obviously x times x. So I got to do a little thinking here. I got negative 9 and 1, 1 and negative 9, or negative 3 and negative 3. Well, I need them to add up to 0, so I'm going to do 3 and negative 3. That way those two add up to 0, because we really have a 0x in here. It's really x squared plus 0x minus 9. So now I got it. It's now finally, I'll write it right above here, x plus 2, x minus 2, x minus 3, x plus 3, and that's equal to d of x. All right. And then the very last one, another one very similar, but this time they gave us 3 factors, so that makes it a little bit easier. So here we go. Let's start out with the very first one. So 4th power. So we're going to start with the box with 4 columns. All right, we are going to write our first term right here, the 4x to the 4th. We'll put our constant over, actually our constant's 0. Oh shoot, this is supposed to be a plus or a minus. My slide is wrong. That is supposed to be a plus. Okay. Oh, wait, no, it's not 0. It's 30. Sorry. There we go. All right, now also remember you have a, make sure that you're going in order. 4, 3, 2, 1, 0. Okay, cool. We're good. So I'm going to just start with the, I don't know, I'll start with the x plus 3. All right, so that's going to be a 4x cubed. Multiply that out. 12x cubed. And these have to add up to negative 15x cubed. So that's going to be, what is that going to be? That's going to be negative 8. No, that'd be negative 15, negative, hang on here. Here, if I can't figure it out, 12 plus x equals negative 15. You can just kind of make a little equation with what you're thinking. Oh, it's negative 37. I would have had trouble with that. You might have too. So you add these up, we get negative 15. Okay, so that would have to be a negative 37x squared, negative 9x squared. These have to add up to negative 48. So negative 9 plus what equals negative 48? If you're not sure, just write it out. So that'd be negative 39. I'm going to erase all this so I got some space. So that would be x times negative 39x. So then when I multiply here, I get negative 109 x. I'm sorry, not x squared, it'd be x. And then I need to get a positive 109 right here. So that would have to be a 208. And then when I add that up, I get the, uh-oh, something's not right. That doesn't make any sense. Because 109 times 3 is not 30. So I don't know. This problem, I might just throw this problem out for now because I don't know if my sign was wrong. My slide came out messed up with this one. So these numbers might not work out. So I'm going to just eliminate this one for now. But you get the idea. All right. So our goal, I can divide polynomials by using the box method. I would highly recommend checking out your Delta Math if you have Delta Math, www.deltamath.com. There's a really good practice unit on there that is interactive where you fill in each box and it checks it for you. All right. So let's see here. Let's do one more. Let's see here. So this one is kind of easy because we have a quadratic. So we're just going to do a 2x2 box. We put the negative 4x squared there and the negative 15 here. So this has to be x and 3. So now I can say, oh, okay, this would be negative 4x to get here. Then I can multiply these two. And then negative 12x has to add up with something to get negative 17x. So that'd be negative 5. X times what would give me negative 5x? That's negative 5. And then check if that all works. So your answer is x plus 3 times negative 4x minus 5 equals e of x. All right, now why is that useful? Because now I can get my x-intercepts. I know my y-intercept is right here. That's my y-intercept. My x-intercepts are now x equals negative 3. This one I might have to make an equation because I might not be able to do it in my head. Add 5 to both sides. Divide by negative 4. You get, those are your x-intercepts, okay? All right, the last one. So rewrite, here's a blank diagram. Okay, so we don't need all this box. We're going to just say cubes. I need 3 columns. And we'll start with a linear factor. So I'm probably going to just start with that. and I'll say that my 4x cubed goes here, and then I'll start with the x plus 1. So x times 4x squared, 4x squared times 1, and then these have to add up to negative 11. So that's going to be negative 15x squared. X times negative 15x would work here. This would be multiply these. These are easy when you have the outside. This negative 15x plus what would give me negative 6x. So I think that would be positive 9x. I guess I don't need the plus in front of there. X times 9 would give me 9x, and then that would give me 9, and it checks out, okay? So I got it down to x plus 1 times 4x squared minus 15x plus 9. So this one I got to make a 2 by 2 box. A little crooked. So I put my other factor. I already used the x plus 1, so I need to use the x minus 3. This was nice that they gave us two of the factors. Put the 4x squared here and the 5 here. So x times 4x would give me the 4x squared. And then I can multiply that. And let's see here, 12x. I need to get negative 15x, so that's going to be negative 3x. So x times, my 9 looks like a 5. Whoops. I knew it didn't make sense because the numbers weren't matching. So x times negative 3, and then negative 3 times negative 3 gives me 9. So that works. So my final answer as linear factors is we had the x plus 1 still, and then we got these two new ones. We got the x minus 3 and then the 4x minus 3. Really, they gave us these two here. This was the only one we had to find, really. So there's your new function, which is p of x, okay? X-intercepts are negative 1, 3, and positive 3/4. Y-intercept is 9. It's always the constant. And behavior, because it's odd, positive, and behavior looks like that. So you do kind of have enough information to sketch a real rough graph from there. All right. All right. Hope you enjoyed this lesson. Thank you for watching. Sorry it was kind of long.